I'm creating this video because I have noticed that even though I'm creating reading materials according to the reading levels, to your reading, you are not reading the materials. So this is my last attempt to try to engage you into the biology course. As I have been telling you for the past quarter, you have a test at the end of the school year, and it's a test that is heavy in reading passages that you have to read and be able to get information. That I'm creating this video doesn't mean that you don't have to read. You have to practice your reading skill as much as you can in order for you to be able to pass the test. This lesson is about the property of the water, because water, remember that your body and that the earth, 75% or like 3/4 of the air composition and your body composition is water. So water is super important for the environment and it's super important for living things. So it's important that we discuss the property of water and that you see how these properties are helping, to conserve and are helping living things just to stay alive and thrive in our environment. First, I would like to start with the table that I have over here, and in this table you have listed all the property of the water. And I want you to look at the freezing and melting point, and the boiling point, okay? The ability to melt at 0 degrees and the ability to get into the solid state at 0 degrees and the ability to evaporate or become water vapor at 100 degrees makes water special. And why it makes water special? Because that means that you're gonna be able to find water in nature in the 3 different stages. Because 0 degrees is cold, but you know that in certain states we are able to reach that temperature during the winter. 100 degrees Celsius, we are not able to get that in any stage, but we have certain environments in which we can find the temperature here on Earth. So the state of matter is important. The state of matter or water is important because at 1 atmosphere, which is a standard or normal condition, we're gonna be able to find water in the 3 different states. 3 different states of matter. Okay? Solid as ice, liquid as water, and then as water vapor in the atmosphere. Then we have the density. Okay, you know that the density is a physical property that can be calculated, divided the mass by the volume. Now, what happened? I don't know if you remember that from physical science. That when the particles, they are in the solid state, they are close together vibrating in place. Okay? They are close together vibrating in place, and in the case of the water, they're gonna create a crystal. Now, when they are in the liquid state, the particles, they start moving faster because they have more kinetic energy. Since they have more kinetic energy, they're gonna be able to slide, or pass each other. Now, in a normal liquid, when you go from liquid state to solid state, in the particles, they are close together, the volumes tend to decrease, but not in the case of the water. Okay, so the volume, when you go from liquid all the way through solid in water, the volume expands or increases, and we call that the anomaly of the water. Now, look at the formula one more time. When you have a mass that is a constant, and the only thing that you're changing is the state of matter, if the volume increases, okay, as you go from liquid all the way through solid, the density decreases as well. The density decreases, and you see that over here. The density of the liquid is higher than the density of the solid. And that's why when you put ice in a cup of water, the ice is gonna float. Why is this important? It's important because, okay, let's say that you are in the North Pole and in the South Pole, the South Pole. You are gonna be able to see the icebergs floating in there. Iceberg. See? During the winter, you will see the ice floating, but it's not gonna sink. Okay? Since the ice is not able to sink in seawater, it's easy to melt during the summertime. Now, what happened? That the water is gonna freeze over here at the surface. That's what we call the ice cap. But underneath, you're gonna be able to have liquid, which is important for marine ecosystems. A fish is not gonna be able to survive inside an ice. Okay? But if you have an ice cap and under that you have liquid water, they're gonna be able to thrive over the winter. And that's why the state matter and the density of water is so important for living things. The density in that case is because solid water is not gonna sink, making the marine life to flourish, or the marine life to survive, not to flourish, to survive during the winter under the ice cap. Now I'm gonna explain a little bit of the chemistry of the water so you can understand solubility and the polarity of the molecule. The polarity of the molecule is super important for solubility. Its solubility is super important for transferring ions and nutrients across membranes when we're talking about cellular process. Now, water is made of 2 atoms of hydrogen and 1 atom of oxygen. Yeah, I don't know, you learned that in physical science, that the atomic number for hydrogen is 1, meaning that hydrogen is going to have inside the nucleus one proton, and floating in the cloud 1 electron. Now, for oxygen, if you look at the periodic table, oxygen has an atomic number equal to 6, meaning that inside the nucleus it has 6 protons and 6 electrons. In order for elements to be stable, and this is why elements combine, in order for elements to be stable, they need two, or they need a electron in the last level of energy. Neither of them is, fulfilling that condition, because you have hydrogen with 1 electron on the last level energy, see, 1 electron on the last level of energy, and then you have oxygen that has 6 electrons on the last level of energy. Miss Ramos, why 6 and not 8? Because on the first level of energy, oxygen is going to be able to accommodate 2 electrons. On the second, 6. That's why it has 6 and not 8. Okay? Now, neither of them fulfill the Opte rule, so they need to start sharing. They are going to start sharing the electrons in order to become stable. Sharing because they are 2 nonmetals. Oxygen and hydrogen are 2 nonmetals. 2 nonmetals. So the electronegativity of oxygen is not that big that he can steal this and become an anion. Okay? Impossible. So they're going to start sharing, because sharing is caring. And then you have over here a molecule of water in which oxygen is sharing 1 pair of electrons with 1 atom of hydrogen, and sharing another pair of electrons with another atom of hydrogen. The electronegativity of oxygen is not as strong as needed to steal the electron from hydrogen. Still is higher than the electronegativity of hydrogen. And that's why they're gonna be sharing the electrons unequally, meaning that hydrogen is gonna be pulling the electrons over here to the nucleus, which is gonna make the oxygen partially charged with a negative charge. Since the oxygen is stealing the electrons, the hydrogen is gonna become partially charged with a positive charge. You don't have an ionic bond in here, but you have a polar covalent bond with a molecule that have partially positive and negative charge. Why is the polarity of the water so important? Okay. It's important because that makes water the universal solvent. When you make a solution, remember a solution is a mixture in which you are unable to see the components. You have a solvent, and then you have a solute. For example, let's say that you have salt. This is the chemical formula for salt, NaCl. Na, that's sodium, which is a metal. Chlorine, non-metal. Okay, so over here you have a cation and an anion in an ionic bonding. You know that if you put salt in water, the salt is gonna dissolve. Why? Because now you have a molecule which is negatively and positively charged, partially, okay? And when you put that salt over here in the water, the sodium, which is positive, is gonna get attracted to the oxygen. The chlorine, which is the negative, is gonna get attracted to the hydrogen, forming a solution full of sodium ions and chlorine ions. This sodium ion is super important for cellular transport. We need this inside the cell. Okay? So in order to put these ions inside the cell, the sodium has to be dissolved in water. And the sodium is gonna dissolve in water, and it's gonna form an ion because of the polarity of the water. The same happens with the sugar. Okay? So you know that the molecule of glucose has 6 carbon atoms, 12 oxygen, 12 hydrogen, 6 oxygen. Non-metal. So this is not an ionic compound. This is a covalent compound. However, when you put this covalent compound in water, it dissolves as well. Why? Because as the water, this compound is a polar compound. It's not gonna dissociate. So the glucose is not gonna dissociate into the ions. But it's gonna form, okay? It's gonna bond. The partially positive side of the molecule is gonna bond to the partially negative side of the water molecule. And that way it's easy for the molecule of glucose to go through the cell membrane. When it's needed inside the cell, you know that for cellular respiration you need glucose inside. So why the polarity of water is so important? Because it makes the water the universal solvent. Water is gonna be able, let me go over here. The polarity is important because water is able to dissolve to dissolve more substance, more substance, more substance. That's why it's important the polarity of the water. Water is gonna be able to dissolve polar covalent compounds, and I know that you don't remember any of this from physical science, but also it's gonna be able to dissolve the majority of the ionic compounds. Yeah, I don't know if you have heard about magnesium, and you have heard about the iron, and you have about a lot of, the metals that we have on the periodic tables. All the metals, see, not all of them, but the iron, the magnesium, they are super important. The calcium, okay, they are super important for living things and super important for human beings. How do they get into your cells? Dissolve into the water. Okay, they cannot get into your body if they are not dissolved in water. The polarity of the water is also important for the surface tension and the capillarity action of the water, which are two other physical properties of water. As I was explaining before, see, the molecule of water is partially charged. Oxygen is going to be partially negative. The hydrogen is going to be partially positive. But when you have a lot of molecules, the positive part of the molecule is going to be attracted, see, to the negative part of the molecule. The negative part of the molecule is going to be attracted to the positive part of the same molecule. In chemistry, we call that intermolecular forces, which is the attraction force between partially charged molecules. Okay? You have water with a part of the molecule that is negative, the other part of the molecule is positive. So when they get together, the positive part is gonna get attracted to the negative part to the positive part, and we call that intermolecular forces. And in the particular case of the water, we call that hydrogen bonds. They are not bonds, okay? According to the definition that you have on your book, the tendency of similar molecules to form weak bonds and stick together is called cohesion. But they are not bonds. They are intermolecular forces that are keeping like a bunch of molecules together. In the particular case of water, okay, this polarity that is keeping, all molecules together through hydrogen bonds is causing that the water has a high surface tension. Its surface tension is when all the molecules are pulling down onto the sides, creating a layer that you can see on top of a lake, a layer that you can see on top of the sea. See, that layer is super important for certain organisms, and you have an example over here. There are insects and different animals that are not heavy, because if they are too heavy, that's why we cannot walk over the water, because we are too heavy. But if the organism is, light enough, that organism is gonna be able to walk on top of that layer that is formed because of the attraction between the water molecules. Important for the survival of different organisms in aquatic ecosystems. Okay? That's because of the polarity of the water. Thanks to the polarity of the water has a high surface tension, which is super important for organisms in freshwater ecosystem. Okay? Freshwater ecosystem. Now, adhesion, okay, is another property of the water, which is the tendency not to stick to similar molecules. Is the ability just to stick to another surface. Because of the polarity of the water molecules, then water is gonna be able to stick to different surface. And water has a strong adhesion. I don't know if you were performing an experiment addressing density when you were in physical science, but in science we have an instrument that is called a graduated cylinder. A graduated cylinder. And the graduated cylinder is the instrument that we use to measure, the volume of liquid with precision and accuracy. When you put water, and that doesn't happen only with water, because you put over there alcohol, is gonna happen the same, because adhesion is the ability just to stick to different materials. So when you put a liquid inside the graduated cylinder, you are gonna be able to see like a curve in there. We call that the meniscus. Meniscus. And that meniscus is forming because the material is attracted. Meniscus. Because the material, is attracted to the side of the container, forming the meniscus. And then you read the volume over here in the graduated cylinder. That property that water has, and other liquids as well, but in this case we're talking about water, is called adhesion. And that property is super important for capillarity action. Capillarity action. Thanks to the capillarity actions, water is able to move up and down the vascular system of plants. Water is able to move through your veins, circulatory system. Thanks to that capillarity action. And this is the last property that we're going to discuss today, which is the specific heat of the water. As you can see over here, the specific heat is the amount of energy. See? You have here joules, unit of measurement for energy, needed to raise the temperature of 1 gram, which is the mass, 1 gram of a substance by 1 degree Celsius. The specific heat of the water is very high. When you think about that, very high. And I want to go back to the beginning. 75% of your body is made of water. Let's say that you are running. If the specific heat of water is low, you're gonna overheat faster, and then you will die, because your cells, they're not gonna be able to survive at 40 degrees Celsius. They're gonna die. After 41 degrees Celsius, they're gonna start, dying, because that temperature is too high for them. Since 75% of your body is made of water, when you start running that mile during PE, you start sweating. Remember homeostasis? I don't know if you have seen that before. Homeostasis is one of the characteristic of living things, the ability to keep internal stable environments, and your body is gonna use water for that purpose. Because it's gonna take a lot of energy to cool down, and a lot of energy just to increase the temperature by 1 degree. It's like a regulator. And in order to change that temperature by 1 degree, a lot of energy is required, meaning that you're going to be able to jump, meaning that you're going to be able to run, meaning that you're going to be able to do all of that, and still the water inside your body is going to be able to keep an internally stable environment. This specific heat of the water plays an important role in homeostasis. Also, it's important, because I don't know if you have heard that for the sea, like a body of water to get warm, it takes more time, than a piece of land. See, so a lake or an ocean is gonna cool down or is gonna warm up like slow, like a slower than the continent, like a piece of land. And that is super important for wind patterns and convection currents and all that. But we're not gonna talk about that. Okay, we're not gonna talk about that because that's about weather and earth science. Here we're talking about a specific heat of the water as a regulator. See, as water keeping internal stable environments. That happens with the cells. Okay, the cells.